So the question here is as follows. A building contractor tendered for two independent contracts, X and Y. The probability that he will win the contract X is 0.5, which is the same thing as 50%. The probability that he will not win contract Y is 0.3, so that's like saying 30%. The question now is, or the questions are the following. What is the probability that he will win A, both contracts, B, exactly one of the contracts, and C, neither of the contracts? So we're going to visit each of these questions. They're really easy, and there are at least two ways to do it. You can use tree diagrams, you can use just intuitive probability thinking, and you can use Venn diagrams. So here we go. So there's just quite a few things to point out before we proceed. I'm going to use I'm going to use a tree diagram to solve this, but I just want you to notice that there are two events: the building contractor tendering for contract X and the building contractor tendering for contract Y. These are two events, and the way you identify events are by looking for occurrences that have outcomes, that can have a number of outcomes, probably one outcome or multiple outcomes. So if you think of the event one where the builder is tendering for contract X or any contract, there are two possible outcomes. He wins the contract or he doesn't win the contract. So let's consider X just before we go to the tree diagram. So X, right? What is the probability that our contractor wins the contract X? It's given as 0.5 from the question. And the probability that he doesn't win X is 1 minus the probability that he wins it. Because you recall, this is a basic probability fact, but if I just, without complicating it, if you recall, the probability of an event occurring is, if the probability of an event occurring is A, the probability of that event not occurring is 1 minus A. That's just an easy way to understand it. I can go a step further and say, well, X and not X are mutually exclusive events. Okay, I hope this is not sounding complicated, but it means that X and not X, or let's put it this way, winning the contract X and not winning can happen at the same time. If you win the contract, that means you won. You can't lose the contract or not win the contract. You see what I mean? So they're mutually exclusive, but there's no need to go into that. So this is the probability of not winning the contract X is 0.5. Something's wrong with my pen today. But if you then go to event Y, there are two outcomes. And let's look at the first one. Probability of winning contract Y is, well, they've given us the probability of not winning contract Y. And that's been given as 0.3. So from what I just said, probability of winning contract Y will be 1 minus the probability of not winning contract Y, which will be 1 minus 0.3, which is 0.7. And for the same reason as above, if you win contract Y, there are only two possible, if you consider event Y, there are only two possible outcomes. You win the contract Y or you don't win it. And they're mutually exclusive. They can both occur. I hope that makes sense. If you have any questions, just ask. But that's like pretty basic. If you win a contract, then that's it. You can't win and not win. I'll stop there. Now that we have this information, we can fill in a tree diagram. So take note of all the information here. So I go to the tree diagram and I've marked the first region to represent event X, and event X has two outcomes. Either you win. Wow, what's going on here? Either you win or you don't win. As we determined just a few seconds ago, probability of winning contract X is 0.5, probability of not winning is 0.5 as well. Now we move to event Y. The probability of winning, we determined it to be 0.7. The probability of not winning we determined it to be, or was given as 0.3. And that's the same thing here. 0.7 and 0.3. So what have I just done? What I'm just saying is, look, we have an event X and there are two possible outcomes. This first branch that points upwards represents winning the contract. The branch that points downwards represents not winning the contract X. Now we move to another event Y. And we're not in the first branch. Again, probability of winning Y, contract Y is 0.7. We just determined that probability of not winning contract Y is 0.3. And that's the same thing here. Why are there two branches? Okay, well, let's look at it this way. If you win, or if the builder wins contract X and wins contract Y, we have this situation here where he's won two contract. If the builder wins contract X and doesn't win contract Y, we have the situation here. And I believe this must be making sense now. If the builder wins contract X, no, doesn't win contract X and wins Y, we have the situation here. And if the builder doesn't win contract X and doesn't win Y, we have the situation here. And because the events X and Y are independent, the probability of both X and Y occurring, so probability of X and Y is the probability of X times the probability of Y. And if you come here, we have the situation where he's won both contracts. That means we're saying the probability that he wins contract X and he wins contract Y. And these are the probabilities that have been used to label the branches. So you just multiply the probability of winning X by the probability of winning Y. And that gives 0.5 times 0.7, which is, I mean, I'll do this a better way. I don't want to use set Venn diagram notation or set theory notation in case you're not familiar with that. So I'll leave it like that. So I'll just do the multiplication and write out the answer. So 0.5 times 0.7 is 0.35. And probability of, well, if you go to this, to get to this point here, we pass through here and here. So that's probability of winning contract X and not winning Y. So that's 0.5 times 0.3. That's 5 times 3, which is 15 divided by 100. So that's 0.15. And then here, the probability of not winning contract X and probability of winning contract Y, 0.5 times 0.7, 0.35. So, I mean, you can easily understand what you do to get the probability here. It's 0.15. So, just to make it clear, I'm trying to avoid using set theory notation, but this probability represents the probability of I mean, you can just follow the branches of, actually I'll label it, of X and Y. I'll use this notation. I should use a different color. This probability here represents winning contract X and not winning contract Y. This probability here represents the probability of not winning X and winning contract Y. You can see this by following the branches. You know, here not winning contract X and not winning Y gives us this situation. Again, I'm just gonna label it so you can see, and we'll use this to answer the question really easily. So what is the probability of winning both contracts? So now we had two events, event X and event Y, and they were independent events, which means they don't depend on each other. What does that mean? It means that if X happens, it doesn't affect the chances of Y occurring, and vice versa. So these two events, so you can have multiple situations. You know, you have two events, and they have outcomes, and at the end of the day, you can have a case where X occurred and Y occurred. You can have a case where X didn't occur. Well, X occurred and Y didn't occur, and you can have a case. Well, there are two more cases. You can have a case where X didn't occur and Y occurred, and finally the case where X didn't occur and Y didn't occur. And by X and Y, I'm talking to winning the contract and not winning contracts. But the beauty of the tree diagrams, it gives you all the possible outcomes of all the events. So we know these are all the possible outcomes of all the events we were given. And now they're now asking us, what's the probability of winning both contracts? Well, there's only one outcome where both contracts are won. Here, where X and Y are won. So probability of winning both contracts is 0.35. Just this. X and Y. So that's 0.35. That's the answer to that. probability that the builder, will win exactly one of the contracts. That means he literally only wins one contract. Which situations do we have? Here he wins two contracts, so we don't look at that. Here he wins X, doesn't win Y. Here he doesn't win X, but he wins Y. So in these two situations, he only wins one contract. Here he doesn't win any contract. So we have the probability that he will win exactly one of the contracts is either the case where he wins X and he doesn't win Y, and the case where he doesn't win X but he wins Y. Because these are the only two situations where he wins exactly one contract, and you need to realize that this here is an outcome. The builder wins contract X and doesn't win contract Y. This here is another outcome that is, I'm going to use that word, mutually exclusive, because you can't have this outcome and this outcome. So you can't have both of them. That's why I say the probability that this outcome occurs or this one. And when you have a situation where you're saying the probability of an event or another occurring, and the events are mutually exclusive, i.e. they both can occur, you just literally add the probability. So such situations, you have probability of A plus the probability of, run out of space, plus probability of B. So what I'm saying here is the probability that he wins exactly one of the contracts is the probability that you have this outcome or this outcome. So you add the probabilities using this rule, which if you've had probability lessons, you must have come across. So this should be like me refreshing your memory. If you still don't understand, leave a comment. So the answer to B is 0.15 plus 0.35, because you're saying this outcome or this outcome, i.e. this is an outcome where he just wins one contract, and this is another outcome where he wins one contract. So it's either this case or this case, because these are the only two possible cases. I'm going to stop there. So 0.15 plus 0.35 gives you 0.5. And finally, question is probability that he wins neither of the contracts. Well, we know from the outcomes that here he wins at least one, and here he wins both. This is the only outcome where the builder wins none of the contracts, and the probability there is right there, 0.15. And these are your answers. So what I've just shown is the beauty of the tree diagram, in that you have a number of events. Tree diagrams can be much bigger than this, depending on how many events you have. But again, just assuming you've covered this in your lessons, you can use tree diagrams to give you all possible outcomes, and then you can just pick and choose and see which one relates to what a question is asking for. So there you go. These are your answers. Well, what can I say? Thank you for asking the question, and hope this makes sense. Have a nice day.